C++ is a powerful, general-purpose programming language that extends the C language with object-oriented features. Now, let's discuss the basic structure and fundamental rules of C++ syntax. First, statements in C++ end with semicolons. C++ is a case-sensitive language, meaning that upper and lowercase letters are treated differently. Blocks of code are enclosed in curly braces, that is, open curly brace and close curly brace. White space, such as spaces, tabs, and new lines, is generally ignored by the compiler. Comments are added to the code using either double / for single-line comments or / and */ for multi-line comments. Here's an example of the basic program structure. It starts with an include statement to include the iostream library. The main function is the entry point of the program. Inside the main function we have a comment and then we print the string hello C++ to the console, followed by a new line. Finally, we return 0 to indicate that the program executed successfully. Let's explore variables and data types in C++. C++ offers various data types to store different kinds of values. Here's a table of some common data types. Int is used for integer values, float for single precision floating point numbers, double for double precision floating point numbers, char for single characters, bool for Boolean values, that is, true or false, and string for text, which is part of the standard library. Here's an example of variable declaration and initialization. First, we include the iostream and string libraries. Inside the main function, we declare variables of different types, such as age as an integer with a value of 25, price as a double with a value of 19.99, grade as a character with the value a, is active as a Boolean with the value true, and name as a string with the value John. These are examples of how to declare and initialize variables with different data types in C++. Now let's explore operators in C++. Operators are symbols that perform operations on variables and values. Let's start with arithmetic operators. The plus sign is for addition, the minus sign for subtraction, the asterisk for multiplication, the / for division, the percentage sign for modulus, that is remainder, plus for increment, and minus for decrement. Next, we have comparison operators. Double equal sign checks if two values are equal. Exclamation mark followed by an equal sign checks if two values are not equal. Greater than sign checks if one value is greater than another. Less than sign checks if one value is less than another. Greater than or equal to checks if one value is greater than or equal to another. Less than or equal to checks if one value is less than or equal to another. Here's an example of operators in action. We declare two integer variables, a and b, with values 10 and 5 respectively. We then use arithmetic operators to calculate the sum, difference, product, and quotient of a and b. We also use comparison operators to check if a is equal to b, and if a is greater than b. The results of these operations are stored in variables. Now let's move on to control structures in C++. Control structures are used to control the flow of execution in a program. Let's discuss decision-making and loops. If-else statements are used for conditional execution based on Boolean expressions. Switch statements are used for multi-way decision based on a single value. For loops are used for looping with initialization, condition, and increment. While loops execute as long as a condition is true. Do-while loops execute at least once. Break statements are used to exit the current loop or switch statement. Continue statements skip to the next iteration of a loop. Here are some examples of control structures. We declare an integer variable score with a value of 85. We then use an if-else statement to determine the grade based on the score. If the score is greater than or equal to 90, the grade is A. If the score is greater than or equal to 80, the grade is B. Otherwise, the grade is C. We also use a for loop to print the numbers 0 to 4 to the console. Let's explore functions in C++. Functions are reusable blocks of code that perform specific tasks. Here are the basic function components. Each function has a return type. Each function also has a name. Functions can have parameters which are optional. Each function has a function body, which contains the code to be executed, and a return statement, which returns a value from the function. Here's an example of function declaration and definition. First, we include the iostream library. We then declare a function called add that takes two integer parameters and returns an integer. This is the function declaration or prototype. Inside the main function, we call the add function with arguments 5 and 3 and store the result in the variable result. We then print the sum to the console. Finally, we define the add function, which simply returns the sum of its two parameters. This is how you declare, define, and use functions in C++. Now let's discuss classes and objects in C++. Classes are blueprints for objects that combine data and functions. This is known as object-oriented programming. Classes have data members, which are attributes, member functions, which are methods, access specifiers such as public, private, and protected, and constructors and destructors. Here's an example of class definition and usage. First, we include the iostream and string libraries. We then define a class called person. The class has two private data members, name and age. It also has a public constructor that takes a name and an age as arguments and initializes the data members. Finally, it has a method called displayInfo that prints the name and age to the console. This is how you define a class in C++. Let's move on to namespaces. Namespaces provide a way to organize code and prevent name conflicts. Here are some ways to use namespaces. You can use the qualified name, for example, standard : coot. You can use a using declaration, for example, using standard : coot. You can use a using directive, for example, using namespace standard. Or you can create custom namespaces. Here's an example of how to use namespaces. First, we include the iostream library. We then create a custom namespace called math. Inside the math namespace, we define a constant called pi and a function called square. Inside the main function, we use the qualified name to print the value of math : pi to the console. We then use a using declaration to use standard : coot without the namespace prefix. Finally, we call the math : square function with an argument of 5.0 and print the result to the console. This is how you can use namespaces to organize your code and prevent name collisions. Let's explore some best practices in C++. These will help you write cleaner and more efficient C++ code. Here are some guidelines for code style. Use consistent indentation, either spaces or tabs. Follow a naming convention for variables and functions. Keep functions short and focused. Use meaningful variable names. Add comments to explain complex logic. And here are some guidelines for memory management. Use smart pointers instead of raw pointers to manage memory automatically. Avoid memory leaks by ensuring proper cleanup of dynamically allocated memory. Prefer stack allocation over heap allocation when possible for better performance. Use RAII, that is, resource acquisition as initialization, to manage resources such as memory and file handles. Let's compare some good versus bad practices. The code on the left shows some practices to avoid, such as using namespace standard, using short and unclear function names and variable names, and failing to deallocate dynamically allocated memory. The code on the right shows the preferred way to write the same code, including the iostream and memory libraries, using clear function and variable names, and using smart pointers to automatically manage memory. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.